the reinforcement, and then concrete were poured on the foundation. See, and then while pouring the concrete, we still have to continue pumping out the water. It's still flowing from the ground and from the walls. There, that's the pedestal that is already being the concrete poured already. So removing the foam works. So there, that's a finished pedestal. And then we remove the sheet piles. And then we backfill for the concreting. And there, so see, that's the concreting of the floor slab. Now, during the excavation work for the foundation, some centuries-old artifacts were accidentally uncovered. These artifacts are now on display in the gallery. The team was focused on doing rehabilitation work on the foundation of the centuries-old house and had no intention of doing archaeological excavations. Some pillars were left undisturbed for future archaeological studies. We left some of the pillars untouched so that in the future, if there's a need to study further about the archaeological aspect of the house, we still have those untouched. So the following slides are some of the artifacts that were unearthed during the undertaking. See, these are porcelains and ceramic shards, potteries, shells and animal bones and dental parts. And then we also discovered a certain old technique in doing the foundation of the house. And we also discovered that there was another structure prior to this house. You see the pictures, 2 pictures below, those are small pillars. Almost 80% of the pillars that we rehabilitate, there's always a small one at the side. So there. Thank you very much.
Thank you so much, sir. For our next speaker, he's actually from the University of Shiga Prefecture, of Ryuichi Ashizawa Architects and Associates. Please help me welcome Ryuichi Ashizawa. A round of applause, please.
Hello, I'm Ryuichi Ashizawa, Japanese architect. Thank you very much for inviting me to this conference. I think there are many problems happening now in Philippines. I was in the local Tacloban and Bohol island a few times this year, and I understood the surroundings. In there, I felt there is not only problems after the disaster, but also there are many problems before the disaster. One of the problem is that housing is insufficient. People living in huts that were built as a first aid and temporary residence that a large number of people over the world have donated. But high density, about sanitation, about security, and many problems still exist. Second is that there are not much infrastructure. My opinion of one solution is to consider creating an environment that doesn't need infrastructure. Third, we need to think about the problems that come from the waste, from mass production and mass consumption. I believe in the possibility to solve these problems in many ways, with design from small scale to large scale. Here, I would like to introduce some of our projects. I hope they can become a reference helping these problems in the future of Philippines. This is a design project that I was thinking the reuse of plastic PET bottles that we use every day in large quantities. This is chair. Chair's legs are plastic PET bottle filled with water. The sitting surface is a resin plate made of reused plastic bottles. This project used many empty cans that were discarded to the city. We pick up the PET bottle and wrote a message on the can. Then planted the seeds and returned the cans to the city. Later, seeds became green. This tree is in front of my office. I placed the planted can 10 years ago. The roots of trees broke empty can and placed on the ground. This is a project that used pressed many empty cans to create a stool. The another subject. This equipment cookers cooking system by creating heat from the harvesting of sunlight. It doesn't need electricity and or gas. We used it in the roof of our office. The day before yesterday, we made curry also too. The vegetables we used also came from our roof garden. This is this is a refrigerator that doesn't require electric energy. Cooling the inside by the vaporization of water placed in the space around the pot together with sun. This mechanism of cooling is used in the tropics. Next to project, my student now trying is a wall reuse of empty bottles. This wall, I think, can work for getting light and gathering temperature for the space. Next one. It was a temporary pavilion for festival in Japan. I planned a large bamboo roof where everyone could gather in the plaza. This is site. In Japan, bamboo was planted behind the house where people lived. They could eat bamboo, and there are many of their belongings that made of bamboo. However, the natural process changed to post-war or mass production and mass consumption society. Now, oil products are very popular, and bamboo is no longer used in Japan. This situation made of a problem of garbage in Japan, and because of its strong vitality, bamboo made many environmental programs to the surrounding forest. So, together with 170 students, we cut down part of the bamboo forest and took those. We thought of taking advantage of the bamboo bending characteristics, bending it to radially. At first, we made the column by bamboo. Then we made lattice roof structure by bamboo on the ground. The bamboo lattice and radius column balance the strengths, modeling a natural shape. This is the final image. Various events we had in the festival time under the large bamboo roof. Everyone very enjoyed. After the event, the bamboo was dismantled and cleaned and converted to paper by traditional craftsmen. And the rest of bamboo would be used for biomass fuels. Using it cyclically, it doesn't produce waste. Next one, I will explain the project of chapel. The name is Sound of Window. The chapel is located near the big lake in Japan, most big lake. Perceived conventionally through the touch, we searched for a way to feel wind by other things, especially hearing. We seek to make from this project an instrument played by natural window. String instrument. I know the stringed instrument called aeolian harp from Greek mythology. We researched about this instrument system. This is an interpretation of the instrument recreated as a space of ceremony. Space that plays sounds when the wind and nature passes through. To capture the window speed we made computer simulations and internal space models. After we installed the model in the field, we conducted an experiment to try to hear the sound. This is a 3D model, a 3D image. The shape of this chapel becomes three-dimensional. Window is created around the strings by the airflow. The strings began to resonance as vibration. The sounds falls in the strings. Closing or opening the window can change the tone of sound. This is outside photo, evening photo. Approach space. This is the inside space. Please listen to sound. Sorry. So can be not listen. Okay, next. This project, next project is extension of existing factory near the jungle in Johor in Malaysia. Normally, factories gives priority to rationality and productivity and economy. This project is a connection with the surrounding ecological environment. We can see the difference between building and nature. The site is located on the seaside. The jungle already stretched and spread to its surrounding, creating a peculiar and rich ecology specific to the region and the site. A large green roof connects with ground extending the earth surface, covering the royal function and extending the ecology of the surrounding jungle. The roof soil improves the efficiency of the factory installation. This is a roof garden. Looks like the real grand garden. The space outside under the eaves, the cool breeze is carried by the heated, vaporized air of the pond during the day. We made 2 big ponds. This is a hut on the roof garden. This structure is rattan. Can take in near jungle. We researched about the in Johor, the Islamic faith is present, and big part of employees is Islamic too. We researched about Islamic architecture. This is Spanish Mezquita. This is National Mosque in Malaysia. We researched about how to make Islamic architecture in this time. The factory space is structurally arranged by hexagon-shaped pillars with a star, shaped top from the arabesque patterns of Islamic culture. This is internal space of the factory. This is the corridor in the factory space. This is canteen. The rainwater comes down from the rooftop and into underground water storage through the pipes inside the pillars, and it is used to watering plants. When flowing into the pond and the window blows, the rainwater that comes down over the rooftop brings a cold breeze to the spaces. To reduce artificial light, the factory is designed to reflect what comes from above. We could predict the amount of skylight reflected using simulations with a panel with arabesque pattern shape. This is a simulation. This is the final photo. In the courtyard, by sprinkler irrigation, we could make a space where people can enjoy and watch a rainbow in the courtyard. This is a rainbow photo. This is the top right of the third floor canteen. This is a prayer room. It was designed to follow the arabesque pattern of the floor tile. I'm sorry, I pushed mistake. Another button. Oh, just a minute, please. The high-rise building has an office function. It is aligned with the east-west axis for a minimal effect of solar radiation on its outer wall surface. The slab around the high-rise building is a slope that connects with the ground level, making a walking path for the workers. It aims to workers' exercise. The plants were selected from the ones living in jungle around Malaysia. We plant green filter to protect inner space from direct sunlight. This is office space. Surrounding, it's difficult to understand. Surrounding is green filter. This is a spot in the top floor of the tower. The jungle can be overlooked from the bus. Finally, this is final project. This project is a proposal plan for reconstruction for Bohol region after earthquake. It was designed to replace all the small fisher village. It's a project that use the forces of natural light and gravitational pull from the moon and sunlight and waves and heat. This is the idea of breakwater. I think I propose this breakwater can make energy. This is a fishing facility under the webbing slab on earth slab. This design works to protect ships from floating anywhere. This is a community space on the sea that can make energy in the floor, in the sea. This is a memorial park in the low area. Because the lower level is very, very dangerous for habitation. This is a housing image on the slope of mountain. I think how to make architecture less damage to the mountain natural environment. This is a final full image. I would like to propose total design for architecture, landscape, and energy system. Okay, thank you.
Thank you so much, sir. And last but not the least, he will talk about the environmental analysis applied to the urban heritage, the case study of Cadiz. Help me welcome architect Jesus Alberto Pulido from Canon Foundation, Fellow Japan. A round of applause, please.
Thank you very much. My name is Jesus Pulido. I'm a professor from the Faculty of Architecture of the University of Seville, and also at Canon Foundation. First, I would like to thank Professor Jimenez for inviting me to this symposium. So I think I would like to share with you the experience that we had about cataloging the heritage architecture in Spain in the case study of Cádiz with a strong focus on environmental design guidelines that is linked the preservation of heritage architecture also with its environmental values. So the city of Cádiz is located just 2 hours by cars at the south of Sevilla. And it has a mild climate. You see the main data here. Mild temperatures, lots of sunshine, high relative humidity, and a constant regime of breezes. In fact, you see by this old map from the 18th century that the city is actually an island, but it's linked to the mainland today by many bridges. So the city we can find today, the heritage city, that is the old quarter of Cádiz, is characterized by what you can see here. The traditional architecture comes from the 17th to the 19th century, and it was composed by alien influence derived from the condition that Cádiz had as a port with America. So this heritage architecture also has some tradition for intuitive building methods adapted to the climate, we will clarify later. This model of city, you see compact urban tissue with perforations, with narrow streets and also some plazas, some squares, can also be found in other Mediterranean Spanish old settlements like Ortigia in Syracuse and the Spanish quarters in Naples. Here you can see a typical narrow street in the city of Cádiz. The relationship between the height of the street and the width of the street and the height of the buildings is very high, between 3 and 4 times. The houses, traditional heritage houses in Cádiz, are usually built with what we call ostionera stone, that is a very porous stone that builders take from the coast side. And as the main features for the architecture, we can quote the predominance of vertical openings in the facade, use of central courtyards to organize and register the living space, and also a complex system of elements to control, modulate, and administrate solar radiation. Here you can see the central patio, which is glazed in contraposition to the windows at the street that can be protected by louvers, shutters, and blinds. You see more photos. And here you can see what we call the fierro and the balcón. These are the 2 main vertical openings you can find in the street facade, the main facade. These are complex system with lots of layers. We will see later. So our research group in Seville signed a contract with the municipality, the local council of Cádiz, in order to renovate the catalogation for all the buildings, the residential heritage buildings in the old area of Cádiz. So thanks to this work, we could establish some typological features that we would later study its environmental performance. Here you can see this is the old model of Cádiz that was commissioned by the King Charles III in the 18th century. It's made of wood. You can see it in Cádiz Town Hall. So what the local council did was take the old quarter of Cádiz, where about 50,000 people live inside here, and break into sectors. So our team was commissioned to analyze this sector, number 13. Total heritage houses are about 300 or 400 with different types, levels of protection. And in our sector, we could find about 100 houses. We also had to study and analyze not only the houses alone, but also the urban tissue. Here you can see a classification of every street in the old quarter by its width. Less than 4 meters in yellow, between about 4 meters, between 5 and 8 meters, and more than 8 meters width. And here you can see a basic scheme of the street, as I was telling you, very, very narrow, the relation between the width and the height of the street. So after we did our work for the local council of Cádiz, we would produce for each house a file like this. This all comes from a computer database. You pick the code for the house or the name, and here you've got all the data about the catalogation. Because when we say a house has some kind of legal protection, we then ask what kind of protection. Some houses are protected in the whole, whereas others are only protected in certain elements. We also have to provide the basic structural scheme with the most important elements, a brief history of the house, and also specialized bibliography where you can find more data about this specific property. So after this, we decided to continue our work in order not only to make a catalogation of the material values, also about the environmental performance of these houses. So we proposed the local council of Cádiz to continue our work. They agreed. So we continue with this work that also is the material for a doctoral thesis, which will be presented soon. So what was our main objective for this research? We would like to make a step from architectural heritage, there is material values, to environmental heritage. That is also protect environmental and spatial values of these properties. We believe this architecture, as all heritage architecture, respond to a specific climate with very specific design techniques and design patterns. So we would like to clarify these techniques and these patterns in order to help any architect when they face the task to design a new building or refurbish an existing one in this area. So they would have design guidelines in order to preserve these environmental and spatial values. We would employ computer simulations. We implemented formulas for thermal and luminous radiation in computer program MATLAB. And also we use the psychrometric chart in order to obtain the most common design patterns in terms of environmental architecture. In the case of Cádiz, there are many design patterns, but you can achieve comfort through architectural design alone around 90% of the time of the year without using heating nor cooling devices. Apart from computer simulations, we also did a field survey. We placed measuring cells, automatized measuring cells, in many points of 10 representative houses of this old quarter of Cádiz. Also, in the exterior facade, this is called the Fierro. And here I present you the scheme of one of the houses that we measured, located at José del Toro Street, a 4-story dwelling of Isabelino style from the 19th century. So we took this scheme, the narrow street, the access, and the central patio. So we placed 4 sensors in the exterior facade, interior room, interior gallery, and interior courtyard in order to measure these patterns: air temperature, illuminance, humidity in all the sensors. We did measurement campaigns both for winter and summer. So now I'm going to comment some of the most representative results. First, in terms of natural illumination, as we could expect poor illumination in these houses with respect to the dense urban fabric, but in fact, it's not that way. It's the opposite. The amount of sunshine in Cadiz combined with the materials used, that is materials with high reflection coefficient, produce a very luminous natural atmosphere. Also in summer, you see this is the fierro, the protruding vertical opening, the interior room, the gallery, and here would be the patio. We compare the two levels, and also we compare these levels with some CS standards to see if there was proper illumination, and we found out that the levels were really good. For example, in order to carry out some typical house task like reading, cleaning, or something like this, you need about 300 luxes. So here, you see levels are quite more higher. In terms of temperature, the fierro produces increase in the interior temperature of the room about 2.5 degrees. That is compared to a mere conventional modern window that would produce 0.1 degrees. So this protruding element performs as a solar collector. In summer, there is a mild risk of overheating, but in summer these elements are open so the wind can flow from the interior to the outside and vice versa, so the building can dissipate the stored heat. Also, we found out that the more important spatial value for these heritage houses was the complex spatial system between the street, what we call the casa puerta, that is the space that connects the street with the patio, and the patio. So we established that this spatial system should be preserved in every refurbishment or rehabilitation project. These are the solar trajectories for summer and levels of thermal radiation in terms of total radiation and diffuse radiation. We can see that the patio acts as a solar collector, while the street has lower levels than the patio. So this is the system that we would like to preserve in refurbishment or rehabilitation. Also, when we focus in the element called fierro, we find that this is a solar collector, as we said. Moreover, you can operate this element differently in winter and in summer. In winter, you can close this interior folding, so this would perform something like as a trombe wall. In summer, you can open and the constant regime of breeze flows. So other thing, immaterial value that we think should be preserved is recommendation for building use in winter and summer. You cannot use the building the same in all seasons. And also, in order to see if these buildings were insulated or not, of course they were not, but to see if they can dissipate heat or not, we also did a thermography survey on many buildings centered in the fierro and in the glazed patio. We found out that these buildings are poorly insulated, but that's for good, because these buildings do not work by insulation. They work by thermal inertia. So it's a different way of performing. more images. Here you can see the Ostionera stone and the Fierro with different levels of temperature. So here, you can see here the difference between this Fierro is closed, the interior fold, and this Fierro is open. So you can see this stops the heat dissipation, but this one not. Also about the on-site measurements, the measurement cells, something more adding up what I commented before about natural illumination. I said it before. Sea illumination standards, 150, 300 lux. Home activities, casual reading. These are very good natural illumination levels. In summer, we have very high illumination levels, which leads to some overheating according to the Gibboni climate chart, but louvers that can only be found in the street windows, unlike the patio and the inner gallery, can stop solar radiation. In the patio, you cannot find louvers or devices to stop solar radiation. And this is a very typical feature only for the architectural heritage of Cadiz. In the temperature, the most interesting thing is that the patio acts as a heat collector. You see sensor 1 in the street. In winter, when temperature drops up to about 10 degrees, in sensor 4 located in the inner patio, the temperature rises up to 15 degrees. That is because the patio is not open to the breezes, so it can maintain the stored heat. This happens also in summer with a minor risk of overheating. But as I was saying before, Cadiz has a mild climate, so temperatures never rise up to more than 32 degrees. So we can use selective ventilation due to the mild breezes in this peninsula. So you can avoid using air conditioning systems if you know how to operate these buildings. And for relative humidity, the most important feature is that you can find relatively high levels, and this helps in order to stabilize thermal oscillations. This, combined with the wind speed, can help these buildings to dissipate the stored heat in the summer nights. So, in order to conclude this ongoing work that will be presented soon in the doctoral thesis, and after that to the local council of Cadiz, we would like to stress that the new design in Cadiz, we present this case study, but I think these design techniques or design guidelines can be applied to every architectural heritage in the world. This design should assess the environmental performance of ancient dwellings. If you are refurbishing an old building or you are making a new one, we think designers should respect this environmental performance. Also, in the city of Cadiz, we have realized that you cannot study the buildings alone. You have to study them together with urban planning, with urban tissue. And every retrofitting strategy centered on human comfort and environmentally conscious architectural design should take into account both architectural and urban design. In Cadiz, it has been proven by on-site measurements and computer simulation, these ancient structures, these houses with the patio, with the complex spatial system, respond to a specific climate. So that implies that such an urban sieve is, in the case of Cadiz, the most powerful tools or the most powerful device by which the inhabitants deal with climate. Why? Because comfort conditions can be obtained at all seasons only by means of architectural design. As I was saying before, according to psychrometric chart, only 10% of the year you can use or you should use heating or cooling devices. So in order to end the presentation, we would like to stress, and we will propose to the local council of Cadiz for this thing, that a revision of the corresponding legal framework, which allows for greater flexibility in design proposal regarding their use, should be considered. I would picture it with an example. Many of these old houses have been converted into apartments. When the refurbishment project is undertaken, they refurbish these buildings with modern building code standards. And in the case of Cadiz, this destroys the environmental performance of the building. For example, when you use airtight windows, the building cannot breathe. When you apply modern construction materials, the building cannot breathe. And in modern apartments, people start complaining about moisture stains, and they say, "Wow, I have invested so much money in my property, and now I'm in the worst condition than before." So we think there should be a revision for the legal framework to allow these buildings to be restored, taking into account environmentally conscious architectural design. So that's the end of my presentation. I'd like to finish with the photo of the glazed patio. So thank you very much.
Thank you so much, Señor Polito. And we request the speakers to please come in front for the open forum. With the help of our moderator, Kazuya Morita from Morita Architects in Japan, with Koji Mabuchi from University of Shiga Prefecture. So if anyone has questions, please raise your hand so we can approach you with the microphones.
Okay, I'm Kazuya Morita, architect based in Kyoto, and now I'm going to moderate this discussion. And is anybody have some questions? Thanks for the presentation. There's a lot of projects and examples having a lot of images or causing inspiration for the future project. So, yes, please.
This question is for Professor Miyake. Here. You mentioned about the perils for the ecclesiastical heritage structures, and one of them is vandalism. Then when you mentioned that, I was thinking of a church here in Cebu, which was made in a neo-Gothic style during the American period, but since then it has undergone 3 revisions, making it bigger and wider. So now it is actually not vertical anymore, but more of horizontal. But then I wonder if you can consider that as vandalism.
I'm not able to judge that one, because I don't know so much about the cases. But in many cases, sometimes modern intervention has altered, changed quite a lot. But the vandalism has another meaning, or another connotation. The very, I guess, I don't say vicious, but the very hostile will to convert it to another purposes. So, of course, for in many countries, something like it is modernized or it is altered to other functions. But the vandalism is, in the Russian case, it's already, Stalin's case, destroyed. Or in one of the monasteries which I show you in Russia, it was converted into the concentration camp. Because the typology of the monastery and typology of prison, they say it's similar.
So it has to be intentional. I have a follow-up question because you also mentioned that, well, this is another question. You also mentioned that we have to be very patient because the process of restoring some of the churches we mentioned take a very long time. But what would be a good strategy for Bohol where there are so many churches that was destroyed? Should it be restored together, although let them just take its time to finish, or should we just restore one after another?
When I first visited the destroyed, demolished churches over there, I had some images of the experiences in Europe, and I thought that it would take at least 10 or 20. So that was my initial idea. And the initiating period takes a lot of time because of discussion period, and also the research is also necessary. And the decision-making process may take quite a long time. It's because a lot of stakeholders they have the different ideas, so discussion is very necessary. And the church is not the house to have the family, but it is I don't say the family, but it's a big community should be in-house inside. So the most appropriate way, according to my opinion, is one way is we have to be not quick to restore, reconstruct. At the same time, a temporary structure is necessary. So double, if I say the double strategy or double line, will be the, I think is most appropriate.
Thank you very much.
Is there any other question?
Certainly.
More than a question, I have a comment because I've really been impressed by the quality of the four intervention. My comment, and if you like to answer to my invitation or to my provocation, I would like you to do it. But my comment is about how the four intervention talk about different four visions of seeing the new architecture or the old architecture, but always from a point of view very respectful from other, if you want to call it, ideologies. So when, for example, architect Asisawa or architect Arcas try to research the reasons of the good architecture in sustainability, or when Professor Miyake or architect Abelgas try to find a good reason for architecture in the respect of the cultural or architectural element. I think they are talking about the same approach, on my opinion.
Okay, thank thank you for the question. I will answer the part that corresponds